Hi, my name is Nathan Carpenter. I'm part of Team 13. I will be presenting the third design presentation. Our product is a can crusher called the Impress, and I will be going over our team's process for developing it. Within our mission statement, we stated that we wanted our can crusher to be reliable, efficient, and affordable. We did this because we wanted to challenge ourselves as well as create a competitive product that's also very easily marketable. Our primary market is Virginia Tech students because of the requirement in the assignment. Because we have Virginia Tech students as our customers, we decided to send out surveys and interviews to 7 different Virginia Tech students. We made sure to get a variety of different genders and majors within that group so we can get a wide variety of opinions. Once we interviewed them, we gathered a bunch of different customer needs. We interpreted the customer needs. And then from there, we came up with 5 main major customer needs. Those being that the design needs to be space efficient, motorized, multi-purpose, low cost, and reliable. So when generating our concepts, the customer needs were a major concern and something that we considered when designing our concepts. So just going over a couple concepts that we created. The 2 in orange here, they use an electric motor and a linkage movement pen in order to crush the cans. The one here in blue is a manual design that uses user input to crush the cans. The 2 down here, they are hydraulic designs that use compressed air to crush cans. And then lastly, the design in yellow over here is what we eventually went with. So this concept, it uses a linear actuator to generate enough force in order to crush the can. One major bonus of it is it has an electric motor, which fulfills one of the customer needs for it to be motorized. A cool thing about the linear actuator is they generate a very large amount of force, which means it generates enough force to crush a whole variety of different objects, not just cans, so that fulfills another customer need. It can also be fitted with a hinge, which allows us to fold the entire mechanism, which means we can fit it in a small area and it can be stored easy, which fulfills another customer need of it being space efficient. And then finally, we decided to make our frame out of wood, and also a lot of the electrical components that we gathered for it ended up being fairly cheap, so it's cost effective. So it also fulfills that customer need. So yeah, moving on. So because can crushers deal with a very high amount of force, to crush a can requires about 50 pounds of force to actually cause the compression. So since it deals with very high amounts of force, there's a lot of different failure modes where things can go wrong. One of those being the motor burning out. So in order to keep the motor from burning out, we need to let the linear actuator rest for 4 minutes for every 1 minute of use. And if the motor burns out, that's very bad for our customers because the linear actuator no longer functions. The next failure mode I have here is the crushing head breaking. The crushing head is going to be under a lot of force, so it's very imperative that this gets made out of a very strong material so it doesn't break. If the crushing head breaks, you can't crush any cans, so that's also just a huge deal. So that's a big thing we need to keep track of. Another thing is the hinge. The hinge actually, as you'll see in a second when we show the CAD models, the hinge holds the whole structure together. So if the hinge breaks, the thing falls in two. So we have to make sure that's made of a strong piece of material in order to avoid failure. So moving on. Our bill of materials. The bill of materials is mostly made up of hardware pieces and minor electronic components. Some of the major things incorporated within the bill of materials are the linear actuator and Arduino Uno, which we're using to send signals to the linear actuator, and our wooden frame. After we created our concepts, we then took that concept and we created NX CAD models of it. So here you can see on the left our hinge mechanism in action. So you can see here a folded version, the unfolded version, and then in figure 1 over there you can see the actual hinge mechanism in place. And you can see why it's important that this does not fail, because the actual object would split in half. The last figure over there is the ejection gap. That's a feature we designed where once the can is fully compressed, it'll fall through that slot and preferably into like a recycling bin. After we generated our NX models, we created a prototype. So here you can see the unfolded prototype with a can inside of it. And then here you can see the folded prototype. For the most part, assembly went fairly well. We ran into a couple small minor issues we'll talk about in a second, but for the most part, fairly well. One of the main issues right now is it's having trouble crushing cans, mainly due to this hinge down here. So as the linear actuator compresses the can, that hinge causes a lot of sideways movement, causing the arm to become off-center, which puts a lot of weight on that crushing head, and it also in a lot of cases prevents the can from actually being compressed because the force is offset. So that's a major issue that we believe can be improved by finding a better way to secure that hinge so it does not move. Another one of the improvements that can be made is just the overall build quality. We have a couple areas within the prototype that are a little bit rough, like we were using a lot of zip ties. Also, some of the pilot holes were not properly drilled, so some of the screws stick out. So we can make improvements to just the overall quality of it. And then in conclusion, one main takeaway from this is our team did a very good job fulfilling customer needs. Our main concept fulfills every single one of them, and we're getting really good feedback from all the customers that we surveyed. That being said, we do have a downside. Our project is in need of a revision. We need to come up with a new way to secure that hinge to keep it from moving, and it's going to need some more product development time for that before it can be put on into the wider market. So all right, but that's it. So